What's up, guys? Welcome back to the channel. Today, we are tackling something that every system design interview expects you to know. Back to the envelope calculation. What does that mean? Of making quick, rough estimates about how much your system needs to handle. Think of it like this. Before you design a house, you need to know how many people will live in it. Same thing with systems. Before you pick databases, servers, caches, you need to estimate the load. We're talking about the things like QPS, queries per second, storage, how much data you store, bandwidth, how much data flows through the network, server sizing, how many machines you actually need. These aren't exact numbers, they're order of magnitude estimates. And that's the key inside here. You don't need to be precise, you need the right ballpark. An interviewer doesn't care if you say 10,000 QPS or 12,000 QPS, but they do care if you say 10,000 when the answer is 10 million. Let's build the skills step by step. Before we deep dive into the math, let's set a concrete scenario because back of the envelope calculation don't happen in a vacuum. They happen in the context of a system. Let's say we are designing a social media platform, something like Twitter or Instagram. Here the functional requirements are user can post content, text, images, short videos, user can follow each other, user can see the news feed of post or people they follow. Users can like, comment or post. Users can search for content and other user. Pretty standard, right? The reason we define this first is because each feature has different load profile. Posting content is a write operation. Reading the feed is read operation. And in most social platforms, reads massively outnumber the writes. Ratio, that's the first thing you estimate. Keep the requirement in mind because and let me walk you through the key numbers you should memorize. Here is where the magic happens. This is the core of today's topic. Let me walk you through the key numbers and you should memorize. The power of 2's. You first know your powers of 2. 10 to power 8 is equal to 1000, approximately 1 KB. 10 to power 20 is 1 million, that is 1 MB. 10 to power 30 is 1 billion, that is 1 GB. 10 to power 40 is 1 TB, 10 to the power 50 is 1 petabyte. These are your building blocks. These are the latency numbers every developer should know. L1 cache is 0.5 nanosecond, L2 cache is 7 nanosecond, then main memory reference that is reading to the RAM is around 100 nanosecond, then SSD random read. When you're reading from your SSD drive, it takes around 150 microseconds. The SSD disk seek, reading from your hard disk drive, the magnetic hard disk drive is around 10 millisecond. When you send 1 KB over 1 Gbps of network, it takes around 10 microseconds. When you read 1 MB sequentially from memory, it takes around 250 microseconds. Reading 1 MB sequentially from a magnetic disk takes 20 milliseconds. The round trip with the same data center is around 500 microsecond and round trip across the continent is around 150 millisecond. The key takeaway is memory is fast, disk is slow, network is in between. And cross-continent calls are super expensive. We'll discuss about the time conversion which we could use. 1 day is equal to 86,400 seconds, which can be rounded to 100k seconds. 1 month is equal to 2.5 milliseconds. 1 year is equal to 30 milliseconds. We round them to make the math easy. That's the whole point. Let's do the actual estimation and let's estimate our social media platform here. In the actual estimation, our first step will be to calculate the daily active users. We are assuming that there are 100 million daily active users. Then in step 2, we will calculate queries per second. Assuming one user makes around 20 requests per day, the total request will be 100 million into 20, which is equal to 10 billion requests per day. The QPS will be 10 billion divided by 100K. That is the number of seconds per day, which will be equal to 100,000 QPS. This is just the average. We need to also calculate the peak, and peak could be 2x to 5x the average. Calculating that, it will be around 200,000 to 500,000 QPS. That is the peak QPS. We also need to calculate about the storage requirement. The storage requirement could be broken down into text post, image post, or the video post. If we do the text post, 100 million text posts per day will be equal to 100 million into 500 bytes. That is the size of each post will be equal to 50 GB per day, assuming there are 50 million image posts and each post is of 500 KB. So the size will be 25 TB per day. Assuming we have 10 million videos per day, and averaging the size of each video is around 5 MB. Then the total size will be 50 TB per day. Calculation for each type. So the total storage here will be 75 TB per day. For 1 year, the total storage will be 75 into 365. That is equal to around 27 petabytes per day. You understand why companies like Meta have massive data centers. The next step is to estimate the bandwidth. You will be calculating the incoming bandwidth, writes, and the outgoing bandwidth, that is the reads. Assuming it's a read-heavy application, the ratio is 10:1. Based upon that, let's calculate. This will be around 70 per day divided by the number of seconds in a day is equal to 870 MB per second. Now, the outgoing bandwidth, assuming we have 10:1, so it will be, so this is the outgoing bandwidth. The next thing is we'll be doing the server estimations. A typical web server handles around 10,000 to 50,000 concurrent connections. At 100K QPS average, you need at least 200 to 100 amplification servers. For peak, double it or triple. That's just the app tier. You also need database servers and cache layers and CDN layers. Let me just write it down. We need 20 to 100 application servers at 100 QPS. All right. So here is a cheat sheet for you for doing the quick estimation. QPS is equal to DAU, that is the daily active users, into the request per user divided by seconds per day. Peak QPS is equal to QPS into the peak multiplier, either multiplied by 2 or 3 or 5, that is the range. Then storage can be done by number of users into data per user into the retention period, how long the user is being kept for. Bandwidth with the storage per day and seconds per day. Servers can be QPS divided by the QPS per server, and memory for cache could be daily active user into the cache ratio, usually around 20%. If you've done this, you can go to the next step. This should probably take around maximum 5 to 7 minutes. You should not waste much time, but this is very important if you're giving for senior level or the staff level. This is must for that role. All right. So here's how to nail this as an interview. Tip number 1 is state your assumptions clearly. Don't just say we need 100,000 QPS. Say assuming 500 million DAU, each making 20 requests per day. That gives you about 100K QPS average. The interview wants to see your reasoning and not just the answer. Then you should round aggressively. 86,000 per second in a day, K, call it 100K. Similarly, if you're doing around 1048,576 bytes in an MB, call it just 1 million. Nobody will fault you for rounding off. They will fault you for spending 5 minutes on exact arithmetic. Use power of 10. Think in thousands, millions, and billions. If your answer is 47,382 QPS, say it 50K QPS. Always estimate the peak, not just the average. Systems don't fail at average load. They fail at peak load. The peak is typically 2x to 5x average. The last thing is that you should write it down. Use the whiteboard or shared doc. Write your assumptions, your calculations, your result. This shows the structured thinking. The calculation should lead to an architectural decision. Then know when to stop. You don't need to estimate anything. Focus on 2 to 3 most critical resources like QPS for server sizing, storage for database choices, bandwidth for CDN, and network decision. Some of the common mistakes: being too precise. Don't spend 10 minutes calculating that you need exactly 127.4 servers. Say about 130 servers and move on. Precision is the enemy of speed and estimation. The mistakes: forgetting peak load. Average QPS is 100K, great, but your system needs to handle 500K during the peak. If your size for average, you'll crash during the Super Bowl. Ignoring the read-write ratio. A system with 100:1 read-write ratio has completely different needs that to an 1:1 system. Read heavy, you need caches, read replicas. Write heavy, you need sharding and write optimization databases. Not accounting for data growth. This is a very big problem. Your system has around 1 TB today. At 75 TB per day growth, you'll need to have at least 27 PB, that is petabytes, in a year. Design for where you'll be in 3 to 5 years, not today. Okay? Now, don't confuse between storage and memory. Storage is disk, cheap, slow, persistent. Memory is RAM, expensive, fast, and volatile. When someone says we need 10 TB of cache, that's 10 TB of RAM. At $10 per GB of RAM, that's around 50,000 just for cache memory. Very different from 50,000 for disk storage. Then we should not forget metadata overhead. A 5 MB video doesn't just cost 5 MB of storage. There's metadata, thumbnails, multiple resolution, database records, cache entries, search entries. The true cost is often 2x to 3x the raw data size. And last, not validating with the real world benchmark. If your calculation says a single server can handle 1 million QPS, then something is wrong. Cross check your estimates against known benchmarks. Nginx has around 50K concurrent connections. Redis has around 100K operations per second. Postgre can do around 5K to 20K QPS. And Kafka can do around 1 million messages per second per broker. All right, so let's bring it all together. Back of the envelope calculations are not about being precise. They are about the right order of magnitude. Here's the process, step by step. Step 1, define your requirement, functional and non-functional. Step 2, estimate the DAU, daily active users, and usage pattern. Step 3, calculate QPS, average, and peak. Step 4, estimate the storage. Break it down by data type. Step 5, estimate bandwidth, the ingress and the egress. Ingress is incoming data, egress is the outgoing data. Step 6, size your servers, the app tier, the database, the cache, how much size is required. Then step 7 is let the numbers drive your architecture decisions. The key formulas which I already listed down were QPS, that is DAU into requests per second upon 86,400, the peak QPS, storage, bandwidth, cache, server size. Remember the magic number, 1 day is equal to 100K seconds. 1 million requests per day is equal to 12 kps and 1 GB per day is equal to 12 kbps. A web server handles 10K QPS, a database handles 5K QPS, a Redis node handles 100K QPS for simple operation. These operations make the math fast. All right, guys, I hope you enjoyed the session and you learned something today about the back of the envelope calculation. Next, we'll go deep dive into some of the system design use cases. Till then, take care.